Welcome friends to this new lecture on mathematical logic. In the previous sessions, we have talked about arguments, we have talked about how to check the validity of an argument, and we have talked about the various methods of checking the validity of an argument. As a quick recap, we can say that an argument is a sequence of premises followed by a consequence or a conclusion. Checking the validity of the argument essentially means checking whether the consequence or the conclusion can be inferred from the premises. Say for example, if we have n number of premises p1, p2 up to pn, and let us say C is the conclusion, then what it actually means is we are trying to check whether P1 and P2 and up to Pn implication C is a tautology or not. This is what is actually meant by checking the validity of an argument. If this is the case, if it is a tautology, we say that the argument is valid, and if it is not a tautology, then we say that the argument is not valid. We saw that there were two methods of checking the validity of an argument. The first method was with the help of truth tables. But we saw that the method of the truth table had certain limitations. If there are n number of propositions that are going into the premises, then the truth table is going to have 2 to the power n rows. And to the point that the value of n is less, truth table method can be used. But if the value of n becomes more, let us say if the value of n becomes, let us say 5, then the truth table is going to have 32 rows. If the value of n is becomes 6, then the truth table is going to have 64 rows. Now making such a truth table and analyzing such a truth table can become quite difficult. So we opt for the second method, that is the method of rules of inference. In the previous lecture, we have talked about the rules of inference. We saw there were many rules of inference like Modus Ponens, Modus Tollens, hypothetical syllogism, disjunctive syllogism, addition, simplification, conjunction, etc. Today, first of all, we'll begin with revisiting the rules of inference. We will have a quick recap of the various rules of inference, and then we will see how to solve some examples, how to solve or how to check the validity of certain arguments using these rules of inferences. So let's start. Let's begin with having a quick recap of what were the various rules of inferences. The rules of inference, first of all, it was modus ponens. What does modus ponens means? If we have the premises P and P implies Q, then I can draw the conclusion Q. If I have the premise P and I have the premise P implies Q, then I can draw the conclusion Q. Modus tollens, if I have the premise P implies Q and I have the premise negation of Q, then I can draw the conclusion negation of P. Hypothetical syllogism, which says if P implies Q and Q implies R, therefore P implies R. Disjunctive syllogism, which says if P or Q and negation of P, therefore Q. If P or Q is true and negation of P is true. In other words, if P is false, therefore Q is true. The addition rule, which says if P is true, then anything ORed with P is also true. If P, therefore P or Q. The rule of simplification, which says if P and Q is true, then P is true. I can also write if P and Q is true, then I can write therefore Q. Obviously, if P can be true, Q, if this is true, this is only possible when P is true as well as Q is true. Conjunction, which says if P is true, Q is true, then P and Q is true. Resolution, which says P or Q, negation of P or R, then therefore Q or R. So these are the rules of inference. Now I suggest you write down these rules of inference on a piece of paper so that when you are solving these questions, you have a ready reference of these rules of inference. For the sake of simplicity, in the subsequent questions that I'll be showing you in this lecture, I'll be showing all these rules of inference as a table on the side of the slide. But I suggest you make a list of all these rules of inferences and keep them with you as a ready reference. Let's try and solve certain questions using these rules of inferences. This is the first problem of rules of inference. This here I have given you the table of rules of inference as a ready reference. Now the question says these are the premises. The first premise says negation of A implies C and D. Second premise says A implies B, and the third premise says negation of B. Now we have three premises. These are the three given premises. Now again, premises can also be of two types. We have the given premises, and as we'll see, we will apply the various rules of inferences to get at derived premises. We'll see that in a short while, and we have to prove that C is true. This is the conclusion. This is the premise number 1, premise number 2, premise number 3, and this is the conclusion. Now let us see how to solve it. Now A implies B and negation of B. You can see over here modus tollens. P implies Q, similar to A implies B, and negation of Q similar to negation B. So the conclusion is negation of P. So I have negation of A. Now this becomes your derived premise. Now this once again is a premise. Negation of A implies C and D. Now I have negation of A and I have negation of A implies C and D. Now see modus ponens over here. Now I have in modus ponens, what does modus ponens say? P implies Q and P therefore Q. Now see over here, negation of A implies C and D. This is representing P over here and this is representing Q over here. So P implies Q and you can see P over here. So the conclusion is Q. So I can get C and D. This is once again a derived premise. Now if C and D, let's apply simplification over here. P and Q, therefore P. So if C and D, therefore C, which was the required conclusion. So we have verified that this conclusion can be inferred from the given premises. So we can say that this argument is a valid argument. In other words, the validity of this argument has been verified. Let's see another example. Now once again, these are the premises that have been given. The first premise that has been given is P. Second, we have been given P implies Q. Then we have been given S or R. And then we have been given R implies negation of Q. And we have to arrive at the conclusion S or T. Now let us see how to work with this. Once again, P, it is a given premise. It is the given premise. P implies Q, once again given premise. Now I can apply modus ponens over here. It says P implies Q and P. I apply modus ponens on these two and I can get at the inference Q. So this is the derived premise. So now I have Q. Another given premise I have is R implies negation of Q. See modus tollens over here. Modus tollens says P implies Q and negation of Q. Therefore, negation of R implies negation of Q. R implies negation of Q and I have Q which I can read as negation of Q. So P implies Q and negation of Q that leads to negation of R. That leads to negation of. There's another way of using the same thing, another way of doing the same thing. You have been given R implies negation of Q. Right? There is another way of it, another slightly longer way or another way around. If I have this implication, if you remember For the implication P implies Q, the contrapositive is negation of Q. Q implies negation of P. So what is the contrapositive of this? Contrapositive of this will be Q implies negation of R. This is the contrapositive, and we know that the P implies Q is logically equivalent to negation of Q implies negation of P. In other words, the implication and the contrapositive are logically equivalent. So I can say that R implies Q is logically equivalent to Q implies not of R. So here what I have done is R implies negation of Q is logically equivalent to Q implies not of R, contrapositive. Again another derived premise. Now I can use this and this. Now I can apply modus ponens on these two, right? This specifically, this example I have taken just to show you that you can arrive at the same conclusion or same derived premise in multiple ways. So now I can apply modus ponens on these two to come at negation of R. Now S or R is another given premise. I have S or R. I have negation of R. See over here, disjunctive syllogism. What does it say? P or Q and negation of P. So therefore Q. So S or R, negation of R. Therefore S. So using these two and disjunctive syllogism, I get this derived premise. Now I have obtained S. Now see over here the addition rule, which says if P is true, then P ORed with anything is true. So I apply it over here. If S is true, S ORed with anything is right. Disjunctive amplification, or I can say I can call it the addition rule. Right. So I have arrived at the required conclusion. Let's see more examples. Another simple example which says P and Q. P implies negation of Q and R. S implies R, and I have to prove negation of S. Let us see P and Q. I have P and Q. So simplification, or you can say decomposition. It's also called decomposition. The P and Q. So from P and Q I can derive P. Decomposition, or you can say simplification. Right? So P, and if P and Q is true, so P will be true as well as Q is also true. So I can also derive Q from here. If this is true, I can derive both P and Q. So these are both simplification. This is also simplification. Now I have P implies negation of Q and R. P implies negation of Q and R, and I also have P. So I can apply modus ponens on these two. I have A, so P implies Q and P. So what I get is the then part, negation of Q or R, modus ponens. Now what I do is, you remember that De Morgan's theorems, De Morgan's laws. De Morgan's laws says negation of P and Q is equivalent to negation of P or negation of Q, and the dual was negation of P or Q is equivalent to negation of P and negation of Q, right? Remember, in solving these examples, not only the rules of inference but the equivalence laws also play an important role. So I have negation of Q or R, sorry, and R. So it can be solved. It is logically equal to negation of Q or negation of R. Now this is OR, right? See the example over here. Disjunctive. Okay, here is the disjunctive syllogism. I have negation of Q or negation of R, negation of R. So I have negation of Q or negation of R. Let me write it over here. Negation of Q or negation of R, and I have Q. right? Now I can write it as negation of negation of. Now see this over here, disjunctive syllogism, what it says, P or Q and not of P, so I can infer Q from here. So from here I'll infer negation of R. So you can see over here disjunctive syllogism applied on these two over here. So now I have negation of R. I have S implies R as a given premise. Now using modus tollens on these two. See modus tollens, P implies Q and negation of Q. P implies Q and negation of Q. I have negation of P, which is the required conclusion. Right? Let's see another example. It says negation of A or B implies C. Negation of A, negation of C. These are the three given premises. And I have to derive the conclusion B. Right? Let's see how to do it. So I have negation of A or B implies C and negation of C. These are the two given premises. Now I can apply modus tollens over here. P implies Q and negation of Q will give me negation of P, and negation of A or B gives me A or B. Right? Let me write it again for you. Modus tollens says P implies Q and negation of Q will give me negation of P. See over here, this is P, this is Q. P implies Q and negation of Q will give me negation of P, negation of A or B, which gives me A or B. Now I have A or B as the derived premise and I have negation of A as the given premise. Right? So I have A or B and I have negation of, so I have B from disjunctive syllogism of the, so which is the required conclusion. Right? Let's see yet another example. It's a simple example which has a single premise. It has a single premise which says P and P implies Q. And we have to show that Q is a conclusion. Right? So the given premise says P and P implies Q. From simplification, if P and Q, then P. So from simplifying of this, I can have P, I can have P implies, sorry, this is not conjunction, this is simplification, my mistake. Right? So if P implies Q, then P. Right? So from this I can derive P, I can derive this. Now I have P and I have P implies Q. I can apply modus ponens on these two to come at Q, which is the required conclusion. Let's see one last example before we wind up. Now we have these premises, P implies Q, negation of P implies R, Q implies S. Now I have to conclude negation of R implies S. Now this question is different in the sense that the conclusion again is not an atomic proposition. Till now, whatever problems we have seen, in all the cases the conclusion was usually an atomic proposition. But here even the conclusion is a compound proposition. So let's see. P implies Q, given premise. I can say we know that P implies Q is logically equivalent to negation of P or Q. Right? Implication, logical equivalence of implication in the previous lecture we have already seen this. So this P implies Q is logically equivalent to negation of P or Q. We have another premise, P negation of P implies R. So if I apply once again the implication equivalence over here, so I get P or R. See, we have negation of P over here, so I have negation of P, so which gives me P or R. So here you see what I have done is I have not applied any inference rule, but I have applied the logical equivalence of implication. Right? Now I have negation of P or Q. I have P of P or R. Right? Now see the resolution rule. Resolution rule says P or Q and negation of P or see the equivalence P or Q and negation of P or R. So we can conclude Q or R over here. So this is from the resolution law, right? So I have Q or R. Now I apply the reverse equivalence. I apply the reverse equivalence. Now we know that if I have P or Q, right? If I have, let us say, negation of P or Q, it is equivalent to P implies Q. Suppose I have P or Q, so this will be equivalent to negation of P implies Q, right? See over here, I have Q or R. Q or R, it will be logically equivalent to negation of R, guys. The logical equivalence, right? So I have negation of R implies Q and I have a premise Q implies R. So I can apply hypothetical syllogism over here. So which gives me negation of R implies S, right? You might be thinking how Q or R can be written as negation of R implies Q. Please remember, Q or R is logically equivalent to R or Q, as the conjunction and disjunction, both the properties are commutative. So I can rewrite Q or R as R or Q. So now R or Q, apply this. You can write it as negation of R implies Q. That is what is written over. So this is just an idea of how to solve the or how to verify the validity of arguments using the laws of inference. Now, in these problems, we were given the argument in a mathematical form, in a formal form. In the next lecture, we will see how to verify the validity of an argument if it has been given in the informal manner. Till then, thank you.